Okay, so another thing that we need to look at, back from Unit 1, actually it's taught later, but it applies to Unit 1, is L'Hôpital's rule. And I know, excuse me, it looks like El Hospital's rule, but we say L'Hôpital. Okay, so L'Hôpital's rule it's another method for finding limits that uses derivatives. Okay, so you can see obviously why we didn't do it in Unit 1. But the thing you have to be really, really careful about is that it can only be used if when you use direct substitution, you get the indeterminate form. Now, there are a lot of other indeterminate forms. I don't think I have a list of them all anywhere, but there's like 0 minus infinity, infinity minus infinity, infinity to the 0 power, 1 to the 0 power, a whole bunch of different forms. Okay, the only ones that we're going to be worried about in AP Calculus AB, and I'm pretty sure BC as well. So BC, we start to use this a lot. We're only looking for these two forms right here. Okay, so what you're going to do is, or what it tells you that you can do, is that if you get a limit that is in the indeterminate form. So say that we have a limit and we're going to some value a as x approaches a of f of x over g of x, and that when you do this you get 0 over 0. Okay, so if that happens, and I could put an if, then what we can do with that is we can say, well, what that is going to equal is f prime of a over g prime of a. So basically all it's saying is that you just take the derivative of each of these as separate functions, and then you find that value right there. Okay, so that's kind of it in a nutshell, but I'm going to show you kind of how we want to set that up when we're doing it in a problem. Okay, so let's look at one of our special trig functions. And we didn't, again, excuse me, we didn't know how to solve that. And we just said, well, let's just memorize it for now, and then we'll worry about it later on. Okay, so we said something like this. Okay, and hopefully we memorized that that was equal to 1. But even with the squeeze theorem, that one's still kind of difficult to do. So let's look at L'Hôpital's rule. Okay, so if I do this, I'm going to get the sine of 0 over 0. And again, I'm not going to put equals because it's 0 over 0 and nothing can equal that. Okay, that is the indeterminate form. Now, when you use L'Hôpital's rule, you always have to state that and show that you have found the indeterminate form. What ends up happening is that people try to use L'Hôpital's rule for things that they can't. Okay, so part of the problem, you've got to show that, and you have to say that. Okay, and then you're going to say use L'Hôpital's rule. Now, seems to be okay to put that, but again, you have to say that you're going to use that rule right there. Okay, so the way that we're going to find this is that we're going to go, all right, we're going to show that this is the limit as x approaches 0 of the derivative of the sine of x. Well, derivative of sine is cosine over the limit as x approaches 0 of 1. Now, notice that I wrote this limit out twice, okay? You have to find them as two separate functions. Don't try to use the quotient rule. Okay, so this would be the cosine of 0, which is 1. This would be 1, it's a constant function, and there's my solution. Okay, so if I were doing this using L'Hôpital's rule, remember, you got to say that, got to say that, show that. But it's kind of a nice little backup. Sometimes you could use this on anything that gives you the indeterminate form. Okay, Okay, let's look at something that looks a little bit bigger. Let's say we have the limit as x approaches 0 of e to the 5x minus 1 over 3x. Okay, so this would be e to the 0, which is 1, 1 minus 1. Okay, I'll put 1 minus 1 over 3 times 0, which is 0. So, and you can go ahead and say, I'm going to let you do this indeterminate form for right now, because I just don't want to make this painful. Okay, so I've said that, I've said that. Now I'm going to write this as two separate limits. So I'm going to do the limit as x approaches 0. Okay, so again, don't use the quotient rule. I'm going to use the derivative of the top. Well, that's 5 e to the 5x over, and again, I'm going to write limit, and people forget to do this right here. The limit of 3x is 3. Well, this is going to equal 5e to the 5 times 0 over 3. E to the 0 is 1, so it's 5/3. Okay, so L'Hopital's rule, not too bad. Let's see if we've got some other examples. Let's say that we had something like the limit as x approaches infinity of the natural log of x over x. Okay, so in this case, I'm going to get the natural log of infinity over infinity. Well, the natural log of infinity would be infinity. Okay, that's another one of our indeterminate forms. Okay, so we're going to use L'Hopital's rule, and we're going to write the limit as x approaches infinity of 1 over x, the derivative of natural log, over the limit as x approaches infinity of 1. Okay, so this is going to become 1 over infinity. And actually, let's not even think about it that way. So 1 over x. Okay, remember that 1 over x? That looks like this. Okay, as we're headed towards infinity, so remember 1 divided by a super, super big number is going to be 0. So it's 0 over 1. That is not the indeterminate form. Our answer to that is 0. Okay, so just keep in mind that, that's not indeterminate. If it's 0 over 0, then it's indeterminate. Okay, another thing that you can do is sometimes you'll do one of these and you do L'Hopital's rule, and it does give you 0 over 0. Well, then just use L'Hopital's rule again until you get a solution. Okay, that's it.